This is the second part to note-taking guide 1.3 from Math 3. So we're just going to check it out and see if we can remember how to do some of the stuff, and then we'll just also show you some new stuff right here. So on this particular example right here, the instructions on example 4 or practice 4 asks you to find all of the relative extrema, which means the maximums and the minimums. So we're really just going to look at the graph here and we're going to decide where our maximums and our minimums are. Well, our maximums come from tops of mountains, like the highest points where there is a change in direction. So we have a change in direction right here, and we have a change in direction right here, which would be considered the top of a mountain. So we're just going to write those ordered pairs down for our maximum. So 1, 0, and we have 3, 0. Our minimums come from what we call, or I like to call, the bottom of a valley, but it's also a change in direction. So change in direction from here or going down to going up, and we're just going to write that ordered pair as our minimum. So 2, -2. So maximums and minimums. Maximums are like tops of mountains. Minimums are like bottoms of valleys. So on this example right here, we have a maximum here. We have a minimum here. So the maximums ordered pair will be not exact here. We're going to have to guess what that is. So maybe -1.7 or 1.75, however you want to call that ordered pair, and then up at 2. And then we have a minimum value that we're going to just do the ordered pair for, and that would be at 2, -1. All right, maximums or minimums on this. So I said change of direction. So let's look at this when we're looking at it. We're going up, 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 and up. So we did not change direction here at all on this graph. So we do not have a maximum or a minimum. All right, this next part asks me to find the x-intercepts and y-intercepts. And then it says, can it have more than one y-intercept if it's a function? Let's remember the function says that it has to pass the vertical line test, which is drawing a straight vertical line through any part of your graph and making sure that that vertical line only touches or crosses one time. So think about that as we do the x and y intercepts, and then we'll answer that question. So x-intercepts is where our graph touches or crosses the x-axis. So we're 4 different x-intercepts here. We're going to list those as ordered pairs, which would be -4, 0, -2, 0, 1, 0, and 3, 0. You can notice that always on your x-intercepts, your y value is equal to 0, and the opposite is true when you're finding the y-intercepts. When the y-intercepts happen, your x value is 0, so you're 0, -1. So going back to that question about the vertical line test, if I have more than one spot where my graph crosses the y-axis, could it pass the vertical line test? And the answer... Alright, there was a little bit of problem in the recording, so I'm not quite sure where it stopped recording. So I'm just going back to this problem, and if we've already done it, I'm sorry. You can just kind of fast forward through the video. But I would rather have it on here twice than to not have it at all. So we're talking about x and y intercepts now, and the question at the bottom says, can the polynomial have more than one y-intercept if it's a function? Now remember that a function has to pass the vertical line test, which says if you draw a vertical line through any spot of your graph, it should touch that graph only one time. So think about that for just a minute as we're finding these x and y intercepts, and then we can see whether or not we decide that it can have more than one y-intercept. Alright, so our x-intercepts are where our graph touches or crosses the x-axis at, and we have that happening 4 times here. So we're just going to write those solutions as ordered pairs. Our first one would be -4, 0. We have -2, 0. We have 1, 0. And then 3, 0. If you notice, our ordered pairs all have 0 for their y value. That happens every time you have an x-intercept. And the opposite happens when you have a y-intercept. So that ordered pair will be 0, -1. So the question is, if we have another y-intercept somewhere here on the y-axis, could I draw a vertical line through this and have it touch only one time? And the answer is no. So we cannot have more than one y-intercept if we have a polynomial function. All right, just looking at x-intercepts really fast. Where's my graph touching or crossing the x-axis? I have 3 spots right here. The first one is at -1, 0. The second one is at 3, 0. And the last one is at 4, 0. My y-intercepts clear up here at 0, 11. This one actually has no spots that it's touching my x-axis, so I would just put empty set there. There's no possible solution. And then my y-intercept was this ordered pair right here, which is 0, 2. This particular case, my x-intercept and my y-intercept are the same. They touch only the x and the y-intercept in one spot, and that's at the ordered pair 0, 0, so it goes right through the origin, which is my x and my y-intercept. All right, this next example right here is an interval of increase or an interval of decrease. So when we talk about intervals of increase or intervals of decrease, we talk about where our slope is positive or negative. So if I'm looking at the slope of this part of my graph, it has a positive slope till it gets to right here. Then it changes to a negative slope until it gets to right here, and then it changes back to a positive slope on this other side. So when we're writing our intervals of increase and our intervals of decrease, we're literally looking at the positive and negative slope, and we're going to write our interval where that happens. So notice the increase, we have 2 parts where our graph increases. It's going to start clear over at -infinity because this graph right here is going to keep going this direction. And then it's going to stop right here where I drew this line at +2 because that's where my interval of increase stops. I'm going to union that though because it starts back up again with a positive slope at 4, and then it's going to go forever in the direction of the right with a positive slope. The interval of decrease here would be this part sandwiched in between here, which is 2 to 4. So again, the interval of increase and decrease has exactly everything to do with the positive or negative slope. So looking here, negative slope, negative slope, negative slope. It changes right here to positive, changes right here again to negative, changes right here again to positive. So I'm going to have 2 intervals of increase and 2 intervals of decrease. So if I'm talking about increase, I'm talking where my graph is positive. My positive slope happens between 1 and 2 on the x-axis right here. And then it happens again from 3 to infinity, so from 3 to forever. My interval of decrease starts clear over at -infinity because that graph's going forever in the direction to the left. It stops at 1, and then it gets unioned with this tiny little piece right here between 2 and 3. So my interval of increase and my interval of decrease are where my slope is positive and negative. Here, my slope is positive, 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 positive. My graph stays positive the whole time, so I don't have an interval of decrease because I don't have any negative slope. And then my interval of increase would be forever to the left and forever to the right because this graph goes forever in both directions. Increase and decrease on this one, positive slope till you get to here, negative slope till you get to here, positive slope from there on out. So the interval of increase would be from -infinity to where we stopped, and it's kind of a like -2.6 or something. Just kind of have to guess. That's my decimal point. It's kind of funky looking, 2.6. And then it starts back up again for positive slope at 0 and goes to infinity. The decrease would be between here, which is from -2.6 to 0. That concludes the rest of the note-taking guide for 1.3. Thanks for watching, you guys.